This is the review of the exercise you set last week, congruency and enlargements. So I'm just going to talk you through the questions, how you should approach them, and also I'll attach the answers to let you know what's going on. So, as always, you've got the sort of the confidence things. Have a look at those. It's going to help you sort of get in the right frame of mind, sort of check, the skills that you need to know. So just some simple multiplications, what's needed for enlargement, and just a bit about sort of real life enlargement, how it works. Okay, so warm up some easier questions. Which of these shapes is not the same as the other two? So you might argue that they're all different, but this one's definitely shorter. This one's just pointing the other direction. Mathematically, these are identical, or congruent is the proper word. And these ones, this one is bigger. These two are smaller. If you imagine sort of spinning this one around, they would be the same sort of shape and size. So B and C are the same, and so A is different. Then understanding just how multiplication and division works is going to help you with enlargement. So 2 times 4 makes 8, 4 times 3 makes 12, 8 divided by 6 is 3, and 15 divided by 3 is 5. Then copy each shape and shade in congruent parts of the shapes, same colors. So this one's been shown for you. Well, in this one, you'd be doing the top and the bottom in one color, and these two side ones in one color. This, you've got 4 shapes there that would be the same color, and this one here is different. What congruent shapes are there in the flags of Great Britain? So you've got these rectangles. You've got this triangle and this triangle congruent, and these two are congruent, but they're not all congruent to each other just because they're triangles. None in the Welsh flag. If you got rid of the dragon and there was just rectangles behind, you could argue they're congruent. And here you've got some of these triangles are congruent, and the ones on the sides, they're different and congruent. Number 4, copy each shape, then split them into the number of congruent shapes shown. First one's done for you. 4 congruent triangles. There you go. 2 congruent triangles. There's several ways you could do it. I would just go straight down the middle though. 2 congruent triangles and 2 congruent rectangles. Now the way I do this is I go down here, and then I just go down the middle here to split this into 2 rectangles. These 2 triangles are congruent. Copy and complete the sentences. Length x is the same as length, u. Length blank is the same as length v, so that's the same as y. Angle A is the same size as angle D, and angle C is the same size as angle E. Okay, so investigations, pentagonals made up of 5 congruent squares that touch side to side. Diagram shows 4 congruent pentominoes. Design your own. How many different ones can you draw? There's lots different ones you can draw. I'd be interested to see what you've got for that one, but I can't really talk about it now because there's lots of different ones you can do. And how many different congruent ones there are? Well, it depends on which one it is, because certain things have got different levels of rotational symmetry. And so some, if you're just using squares like this, you could have 1, 2, 3, or 4 different congruent ones. But if you think about like turning it a little bit diagonal, you could get infinite ones potentially if you just tilt it slightly. Okay, then we move on to enlargement. So scale factor of 2, all the side lengths are twice as much. Scale factor of 3, so you should draw a rectangle which is 3 by 6. Here, scale factor of 5, so this should be 5, 5, 5, 5, 5, 5, 5, 15 across at the top there. And, 3 and 5. So this one you should be doing 3 by 6 and also 5 by 10. And same with this one, I talked about the 5 one, you can have one which is 3, 3, 3, 3, 3, 3, 3, 9. And similar for this one, this side's going to be times by 3 or 5, depending on which one you're looking at. The diagonal one, instead of going 2 diagonal, you'd be going 6 diagonal or 10 diagonal. Last question. In a school play, to make the actors look very small, all the props need to be 15 times the real size. A real DVD case is 15 millimeters thick. How thick would it need to be for the plate? So it needs to be 15 times. So 15 times 15 is going to be 225, and that's going to be 22.5 centimeters. A real calculator is 14 centimeters long. How big is it going to be in the play? So 15 times 14 is going to be, I think, 210. And so that's going to be 2 meters and 10 centimeters, 2.1 meters. Okay, it's a fairly straightforward exercise, I think. If you had any difficulties which I haven't just addressed, then let me know. Otherwise, that's all I've got for today.